Alright, so now that we computed a couple of approximations for the square root of 2, we want to look at automating that process. And to do so, we're going to lean on Python a little bit more. In order to use Python here, we're going to rely on both a new idea in terms of a structure called a list and a tool called a for loop that allows us to repeat an operation over and over again. So let's start by looking at lists, and here's an example of a very basic list of the first 5 integers. 1, 2, 3, 4, 5. We see that a list is formed with brackets and we separate objects in it with commas. Now this list A is a collection, so there's many things in there. If I want to access one of those things, they have indices, which are based on their location. Now Python starts counting at 0, so the first object in the list is index 0, and I refer to it with A bracket 0. Okay? If I want the next thing in the list, it would be 1. And if I wanted to put something else on the end of this list, I would use append. And I can do that by a.append parentheses 6. And now if I look at A, I have another value on there. This helps us because what we want to do is we want to start with a list of approximations. All right, so I'm going to say approximations equals an empty, actually I'm going to put 1.5 in that list, and that's our first approximation. Now our next approximation will be the average of that first approximation. So I'll say approximations 0 plus 2 over that first approximation. And then what we want to do is tack that on to our list. And if we look at this now, right, there's our first approximation. Here is our initial guess. There's our first approximation using the algorithm. Okay, so that's how we're going to use a list. Now, we just kind of want to do this over and over and over again. So we only need to change a little bit about what we have here, and we also want to use this thing called a for loop. So to start, we'll look at a for loop for number in approximations. Let's print that number. And you see what this does is this loops over every object in this list and prints each. So we'll use this for loop to actually count through a few approximations, continuing to do this same thing every time. So let's put this all together. We'll start with our approximations list, and we'll have 1.5 as our first approximation. And now I'm going to create a loop that will count 5 times. So the way that I'll write this is for I in, and there's actually a counter function called range. If we just take a quick look at this, this counts through 0, 1, 2, 3, 4. All right. If I say 5, it counts the first 5 numbers. Again, Python starts counting at 0. So what we'll do is this, the first time through, we want to grab this approximation. So that would be approximations I. That'll be approximation 0, right? And we want to create a new approximation based on that. So instead of saying just the first, we're going to update this every time. And it'll be the next time through, it'll be the second thing in the list. We're going to use this and find the next approximation, and then whatever we get from that, we'll use the next time through. All right, so we're going to have our next approximation be ½ times that previous approximation plus 2 over that previous approximation. And after we compute that, we want to put it on the list so that we can use it the next time through. So then we're going to take approximations and append the next approximation. Okay, and we'll keep this print statement here so that we see what iteration we're on. And we can do that even programmatically by saying, we'll type F and then a single quote, and we are on iteration curly braces I, close curly braces, in a single quote. And what this does is this prints the variable inside of this string here. Let's see how this works. Okay, we're on iteration I, and we didn't get a printout of actually the values, but if we now look at our list of approximations, we see that in fact we have 5 values for the approximation. And we also note that by the end of it, these weren't changing. These last 2 look identical, so maybe this is a good approximation for that square root.